Hey everyone, we're going to go over section 2.1, equations of lines. This should be kind of a review from Algebra 1 basically, so you guys should start to feel a lot better about the material. The first thing we're going to talk about is point-slope form. And if you look at what point-slope form, well, the description of point-slope form, it says that suppose that a non-vertical line with slope m passes through the point x1, y1. You can see that on the graph. If xy is any point on this non-vertical line, so you can see that they have x1, y1, they have this xy coordinate out here, with x not equal to x1, just meaning that this x1 is not equal to x, because if it were equal to x, it'd be the same coordinate. So they're just saying that has to be a different coordinate. Then the change in y is change in y equals y minus y1. The change in x is change in x equals x minus x1. And the slope is m equals change in y over change in x, which is y1 or y minus y1 over x minus x1. And they show that in the figure here. So all they're really telling you is the stuff that you learned in section 1.4, which is given 2 points, the slope of a line is simply just y minus y1 over x minus x1. Now you might be asking, okay, so we did this in 1.4. How does this apply to point-slope form? Well, point-slope form is an equation that's derived from finding the slope of a line. So if we take this this equation here and we multiply each side by x minus x1, that will give us, this will cancel here, so that'll give us x minus x1 times m equals y minus y1. And then we're going to flip this around so it says y minus y1 equals m x minus x1. This is point-slope form. Now, if you look a little bit farther below, you'll see two equations. You've got y equals mx, or y equals m x minus x1 plus y1. That's just this equation here with y1 added to this side. This equation is what I know and what I've used in Algebra 1, which is point-slope form. This equation here is the same equation, they just add the y1 over. But this is what point-slope form is, and you can see that point-slope form equation comes from the equation of finding slope. So this is nothing new. It's just this equation rearranged into this equation. So then it gives you some special properties so that you can actually solve some problems. So let's solve some problems together. It says find an equation of the line passing through the points -2, -3, and 1, 3. Plot the points and graph the line by hand. So if I want to find an equation, I need to use point-slope form. So I'm going to start with y minus y1 equals m x minus x1. And then I need to figure out some things that I need to plug into this. So I need to find the slope. Well, we know to find the slope, we take y2 minus y1 over x2 minus x1. When we do this, that's going to give me, let's call this x1, y1, x2, y2. So that's 3 minus -3 over 1 minus -2. 6 over 3, which is a slope of 2. So now I can plug that in here. So I'm going to start this by saying y minus y1 equals 2 x minus x1. Now I can do point-slope form in two different ways. I've got two different coordinates, so I can do two different equations. For the first coordinate, I'm going to use the point -2, -3. And for the second one, I'll use the coordinate 1, 3. For this one, I get y minus -3 equals 2x minus -2. That gives you y plus 3 equals 2x plus 2. So this is one equation for point slope form. The other equation you can get is y minus 3 equals 2x minus 1, and this is the second one. Now they look differently, but in the next section we can see that they're actually the exact same equation. And I will show you that to you when we talk about slope-intercept form. But this is how you determine an equation using point slope form. Now we're going to talk about slope-intercept form. So the line with slope m and y-intercept b is given by y equals mx plus b, the slope-intercept form of the equation of a line. So this is just an equation that you can write using the point slope form equation. So if we come back to, let's come back to these two equations. We have y plus, get it on the screen here. Come back to these two equations. We have y plus 3 equals 2x plus 2. If we want to, we can write this and this, we can rearrange it so that it becomes this formula. And with this formula, we know m is the slope and b is the y-intercept. It's easier to graph using this formula. So that's kind of why we like slope-intercept form, because it's easy to graph in. So let's take a look at finding equation of a line and then putting it in slope-intercept form. Find the point slope form for the line that satisfies the conditions. Then convert this equation into slope-intercept form and write the formula for a function f whose graph is the line. So they give us a slope of -1/2. So we're going to say part A, m equals -1/2. And it passes through this point. -3, -7. So we can say y minus -7 equals -1/2 x minus -3. Remember, I'm getting this equation from the, I'm going to label this always as PSF, but it's y minus y1 equals m x minus x1. And then this will give us y plus 7 equals -1/2 x plus 3. Now they want us to write it in slope-intercept form. So this is point slope form. I'm going to write that out. We could stop there if they just asked us for point slope form, but they ask us for a slope-intercept form. For slope-intercept form, if you look up above, I needed to get to say y equals mx plus b. So I need to solve this equation for y, and I need to distribute and simplify it. So we're going to subtract 7 on each side. And that's going to give y equals -1/2 x plus 3 minus 7. Now I'm going to distribute, and that gives us y equals -1/2 x minus 3 over 2 minus 7, which equals y equals, or which gives, we don't want to say equals, we want to say this gives y equals -1/2 x, well, this is -1.5 minus 7, that's -8.5. And so that's an equation of slope-intercept form. I can graph that now using the y-intercept, which is -8.5, so 1, 2, 3, 4, 5, 6, 7, 8. So 8.5 would be about right there. And then I can go down 1 to here, over 2, mark it. So this line looks like so. The other one, it says the x-intercept is -4 and the y-intercept is 2. So it wants us to write an equation in slope-intercept form with those. Well, for part B then, we have a coordinate. If the x-intercept is -4, the coordinate is -4, 0, and the y-intercept is 0, 2. So I can find the slope again. So I'm going to find the slope this time. I'm going to take y2 minus y1 over x2 minus x1, which is going to give 2 minus 0 over -4 minus 0, which gives 2 over negative 4, which is negative 1/2. And then I can take this and plug it into point-slope form, which is y minus, I'm going to use this coordinate here. So y minus 2 equals negative 1/2 x minus 0, which just gives y minus 2 equals negative 1/2 x. And when I add the 2 to the other side, I get y equals negative 1/2 x plus 2. So this, I'm going to call both of these slope-intercept forms. This here was point-slope form. So you can see that point-slope form can just be rearranged into slope-intercept form. And then to graph this, it's really easy. This is the y-intercept. So we go to 2, down 1 over 2. And you can see actually these lines are parallel. We'll talk about this later, but these lines are parallel because they have the same slope. So remember that for later. Now I want to estimate iPod sales. So it says Apple Corporation sold approximately 55 million iPods in fiscal 2008 and 43 million iPods in fiscal 2011. Find the point-slope form of the line passing through 2008, 55, and 2011, 43. Interpret the slope of the line as a rate of change. So the first thing I have to do is write down the equation. For point-slope form. And I have to find the slope. So to find the slope, we're going to go 43 minus 43, not 4 minus 3. 43 minus 55 over 2011 minus 2008. That's negative 12 over 3, which is negative 4 over 3. So the slope is negative 4 over 3, but it says to interpret the slope of the line as a rate of change. Well, what was I subtracting on top? I was subtracting millions. So that's minus 4 million every 3 years. Oh, I messed that up completely. I screwed this up right here. Negative 12 over 3 is actually negative 4 over 1. Sorry. Thought that was weird. So that's minus 4 million over not 3 years, but over 1 year. It was minus 12 million over 3 years. That's the whole start of the problem. But the slope is actually negative 4 over 1, which is negative 4 million, so minus 4 million over 1 year. So then I can write the point-slope form using one of these coordinates. So I say y minus 43, I'm going to use this coordinate here, equals negative 4 x minus 2011. And that's my point-slope form equation. Now it says sketch a graph of the data and the line connecting these points. So there's the graph. Estimate sales in 2010 and compare the estimate to the true value of 50 million. So if we're going to pick 2010, what we do is we throw 2010 in for x. So we want to, we're basically saying I want to plug in 2010 for x, so I want to know the function of the input of 2010. So I'm going to say this was part A. Part B is this part, which was the graph. Now part C then, I'm going to say y minus 43 equals negative 4, and then that's 2010 minus 2011, which will give y minus 43 equals, I subtract those, that's a negative 1, so it's negative 4 times negative 1. Y minus 43 equals 4. Add 43 over, and y equals 47 million. So in 2010, we should have projected the sales to be 47 million. If you look on this line, 2010 is right here. And if you look at right there, that's about $47 million. This is actually called interpolation, and we'll talk about that later, but basically interpolation is when we estimate the value of something in between the 2 points on our graph. So in part D, they actually ask us to extrapolate this. So extrapolation is when we pick a point that's outside of the two values that we were given originally. This is making a future estimate, basically. And interpolation is making an estimate that is not in the future, but it's between our two known data points. So let's do that. We'll have y minus 43 equals negative 4, 2023 minus 2011. That'll give us y minus 43 equals negative 4 times 12. And then we get y minus 43 equals negative 48. Add the 43 over, and we get y equals negative 5 million. That's weird. Do you think iPod sales would be minus 5 million? I would doubt that, but based on the slope of this line in our extrapolation, that's what it says. And you can see that that would make sense if you got out in this direction. Now we're going to talk about finding intercepts. So you should remember finding intercepts from Algebra 1. But if not, let's start with standard form. So the point-slope form and the slope-intercept form are not the only forms for the equation of a line. And the equation of a line is in standard form when it is written as ax plus by equals c. So this is just a standard way the equations are written. So point-slope form is a way to write an equation. Slope-intercept form is a form that you can put standard form into or point-slope form into to graph. But this is just our standard way to write an equation. So standard form is when it's written ax plus by equals c, where a, b, and c are constants and a and b are not both 0. By using standard form, we can write the equation of any line, including vertical lines, which are discussed later in this section. Examples of equations of lines in standard form include the following. So standard form equation. Another one, which is y equals 1/4. This is when a would be 0. And this is a case when b is 0. You have x equal negative 3. So actually this is you'll find out later, this is a flat line at 1/4. This is a vertical line at negative 3. And then another one here with just a fraction, and it's the same idea as this one here. So how do you find x and y-intercepts? Well, if I want to know the x-intercept of something, I want to know where it crosses the x-axis. So to find an x-intercept, I want to know where it crosses the x-axis, so I'm going to plug in a 0 for y because that will tell me, obviously, if you're on the x-axis, y is 0. So that'll tell me what this value is. If I want a y-intercept, I'm going to plug in a 0 for x because obviously it's when the line crosses the y-axis, so I want 0 to be in for x, so I make sure that I'm on the y-axis. If you look here, they'll show in this example, so find intercepts for 3x plus 4y equals 12. They plug a 0 in for x, and they're finding the y-intercept, so that gives 4y equals 12. Divide by 4, you get y equals 3. So the y-intercept is 3. So this coordinate then, when they plugged 0 in, that's 0, 3, and you'll see that written right here, y-intercept. And then they plug 0 in for x or for y, and that cancels that out. So you divide by 3, you get x is 4. So the x-intercept is 4, which would be 4, 0. And they have that right there. And then you can obviously graph the line. You got 2 coordinates on the line. You can graph that. Finding intercepts. To find any x-intercepts, let y be 0. I said that. To find any y-intercepts, let x be 0. I said that. And then you solve, obviously, for the variable that is left. So it says locate the x and y-intercepts for the line whose equation is 4x plus 3y equals 6. Use the intercepts to graph the equation. All right, simple enough. I want the x-intercept. So I need to plug in 0 for y. And to do that, I'm going to say 4x plus 3 times 0 equals 6. That's 4x equals 6 divided by 4, and x equals, well, that'll be 6 over 4, which is 3 halves, which is 1.5. And then I'm going to find the y-intercept, and that's going to be a 0 for x. So I plug in 4 times 0 plus 3y equals 6. That cancels out, so I get 3y equals 6. Divide by 3, and you get y equals 2. So my x and y-intercepts are written. If I want to graph them, 1.50 would be 1 right here. 0, 2 would be right here. Draw the line. That's all she wrote. Done. Horizontal, vertical, parallel, and perpendicular lines. So horizontal and vertical lines. The graph of a constant function f defined by formula f of x equal b is a horizontal line having a slope 0 and y-intercept b. So if you notice here, instead of saying f of x equals mx plus b, they're saying f of x equals b. Well, if f of x equals b, then that must mean that m was 0. That's what they're saying right here, is that m was 0. So this has a slope of 0. Anything that has a slope of 0 is a line on the graph that looks like this. That's a horizontal line. It says a vertical line cannot be represented by a function because distinct points on a vertical line have the same x-coordinate. Well, we should know this because we use the vertical line test to test to see if something's a function. If we're using a vertical line to test to see if something is a function, then a vertical line cannot be represented by a function because when we do the vertical line and we draw it up and down, like they said here, the same x-coordinate gives you different values for y, and that can't happen with a function. So they say, in fact, this is a distinguishing feature of points on a vertical line. They all have the same x-coordinate. So whenever you have a vertical line, you have the same x-coordinate, which is why you'll see, like, if I say x equal 3, you're going to see a vertical line at, if you look over at this, so you'd have a vertical line that looks like this. That would be x equal 3. Parallel lines, they're going to have the same slope, and then perpendicular lines will have negative reciprocal slope. And we'll talk about that here in a second. Notice that you have a vertical line here. Each point has an x-coordinate equal to 3. So this is the function x equal 3, which I just showed you on the previous page. X-intercept crosses at 3. Every x value is 3, and then obviously the y values are different. So you have mappings from the number 3 to a bunch of different y values, which is why this is not a function. And they call this vertical lines have undefined slope, and it's undefined because it seems to go on for forever. It's just dropping. The slope is you can't really put a number there because it's not going in the x direction at all. It's just dropping. For equations of horizontal and vertical lines, an equation of the horizontal line with y-intercept b is written as y equals b. An equation of the vertical line with x-intercept k is x equal k. So all they're saying there is whenever you see an equation that's horizontal, you'll see it written as y equals 10. So this will be a horizontal equation. X equal 3, that's going to be a vertical line. And the reason for that is because every x value is going to be 3. In this case, for a horizontal line, every y value will be 10. You can see that down here when you look at these vertical lines here. You have x equal 8 and y equal 5. The vertical line does not represent a function, but the horizontal line is a constant function, which is f of x equal 5. So it says, find equations of vertical and horizontal lines passing through the point 8,5. If possible for each line, write a formula for a linear function whose graph is the line. So whenever they want you to find two vertical and a horizontal line going through a point 8,5, they make that pretty easy. They're saying find the point 8,5, draw a vertical line, figure out what that equation is, that's x equal 8, and then same thing with the horizontal equation, that's y equal 5. Then we get into parallel and perpendicular lines. So notice that these are perpendicular to each other. For parallel lines, two lines with the slopes m1 and m2, neither of which is vertical, are parallel if and only if their slopes are equal. That is, m1 equals m2. So if their slopes are equal, then we have parallel lines. For example, y equals 2x plus 10. Oh, let's do something smaller than that. It's easier to graph. Let's do y equals 2x plus 4, y equals 2x plus 1. If we graph those, we mark 1 here, up 2 over 1. We get this line. Then we mark 4, up 2 over 1. We get this line. And you see the parallel. This is y equals 2x plus 1, and this is y equals 2x plus 4. Parallel lines have the same slopes. So that's the important part there. Parallel lines have the same slopes. Now it wants us to do an example. So find the slope-intercept form of a line parallel to y equals negative 2x plus 5, passing through 4, 3. So this is a new line, not this line. It's a new line we're going to create that passes through this point. So to do that, we're going to use point-slope form. PSF. And we know the slope of the new line, if they're parallel, has to be negative 2. So we put negative 2 in there. So y minus y1 equals negative 2, x minus x1. But I don't want the new line to be the same line. So I'm not going to use anything else other than the same slope here. And then I got to know this new line's got to pass through 4, 3. So I'm going to plug 4, 3 in. So y minus 3 equals negative 2, x minus 4. Now I can put this in slope-intercept form. So I'm going to distribute here. So that's y minus 3 equals negative 2x plus 8. And then I need to add 3 over. So that's y equals negative 2x plus 11. This line is parallel to this line. And this line goes through 4, 3. And I know it goes through 4, 3 because that's what I used to find that equation. So we know it goes through 4, 3. All right, now we're rolling. Let's look at perpendicular lines. So two lines are perpendicular if the product of their slopes is equal to negative 1, meaning they're negative reciprocals of each other. Two lines with non-zero slopes, m1 and m2, are perpendicular if and only if their slopes have product negative 1. That is, m1, m2 equals negative 1. Here's an example. Y equals, let's do 2x plus 1, and then let's do y equals negative 1/2 x. We'll go minus 1. The slopes here are negative reciprocals of each other. I can check. So I'm going to check. I'm going to say 2 times negative 1/2. That gives me negative 1. Right there is what they're talking about. If you take the two slopes and multiply them and get negative 1, that means that these are perpendicular. Now, how do I check to see that it's actually perpendicular? Let's take a little graph. Let's mark 1, for this line up to over 1. Draw the line. Now let's mark -1. And let's go down 1 over 2. That's right here. Now this is a roughly sketched graph. But you can see that's going to make a 90-degree angle right there, which means they're perpendicular. Now it didn't work out exactly right because I did it by freehand, but you guys get the point. So then they have slopes of perpendicular lines, and you guys can take a look at that. I'm not going to talk much about this, but you can see how this works. 1/2, -2, -1. 6/5, -6/5, -5/6, -1, so on and so forth. So take a look at that, and just gotta get a good feel for what perpendicular lines look like. So find the slope intercept form of the line perpendicular to y equals -2/3 x plus 2, passing through the point -2, 1, and graph the lines. Well, I have the lines graphed over here, and you can see that they are perpendicular. But how do I come up with that line, that new line? Well, I want this slope. I want this slope times some number to give me -1. So I need -2/3 times, let's say, x, which we're going to call x is the new slope. That should equal -1. So then if I solve this, I divide by -2/3 on each side. And when you divide by -2/3, the negatives cancel, and you end up with x, flip this bottom number, equals 3/2. So the new slope should be 3/2. So then I use point slope form. And I plug in 3/2 along with the point that I want it to go through. I would like it to go through -2, 1. So y minus 1 equals 3/2 x minus -2, which gives y minus 1 equals 3/2 x plus 2. And then I distribute and add that over, and that gives y minus 1 equals 3/2 x plus 3. Add the 1 over, y equals 3/2 x plus 4. And you can see this line is going to be perpendicular to this line, and if you look right here on this graph, we've got 3/2 here, x plus 4, graphed there, and we got -2/3 x plus 2, graphed here, and they are perpendicular to each other. Now, it says determining a rectangle. In figure 210, a rectangle is outlined by 4 lines denoted y1, y2, y3, and y4. Find the equation of each line. I want to find the equation of each of these lines. Okay. Well, the first line, let's see here. This line starts at 0, 0, and well, what we can do is let's look for 2 points on one of these lines and find that equation first. So let's find the equation of y1. So y1's equation is going to be y minus y1 equals m x minus x1. And I'm going to find the slope. I've got 0, 0, and 5, 3. So my slope is going to be, if you go basically 3 minus 0, so 3 minus 0 over 5 minus 0. That's going to give you a slope of 3/5. And now I'm going to take 0, 0 and plug it in with the 3/5, and I'm going to get y minus 0 equals 3/5 x minus 0, which is going to give me the equation y equals 3/5 x. So the original line here that we have is y equals 3/5 x. Well, then let's go and let's look at what y4 would be. That'd be the best idea. Let's go and say y4 then. I know that this line right here is parallel to this one. I can see it. It's parallel. Well, if this is a parallel line to this, they have the same slope. So I'm going to use y equals 3/5 x. And it's got a y-intercept of 5, so this makes it really easy. I just add 5, and that's going to be the equation for this parallel line. I also know that these other lines are perpendicular to this one. So like y2 is perpendicular to my original line right here. Okay, so this is the original line for y1, this is y2, or y4. So y2 then is perpendicular to this line. So what all I've got to do is I've got to say, okay, 3/5 times some number equals, and I'm going to actually, instead of saying x, I'm going to say s, the slope, new slope. Maybe I'll just use n. Let's use n. 3/5 times n equals -1. So then I divide by 3/5 on each side, and n equals -5/3, which means my new line for y2 then, if it goes through 0, 0, its y-intercept is 0, so I end up with y equals -5/3 x plus 0. So this is the new line there. Remember, plus 0 because this is the y-intercept for that y2 line. So then I want to find y3. Now y3 is going to be parallel to this line that I just got here. So these two lines are parallel to this line here. So I need to use its slope in slope-intercept form, or point-slope form. Sorry, point-slope form. So then I pick the coordinate, which this thing goes through 5, 3, and I say y minus 3 equals -5/3 x minus 5. So then I can distribute. That's y minus 3 equals -5/3 x plus 25/3. And then I can add 3 over, and I get y equals -5/3 x. 25/3 gives you 8.33. Add the 3, and you get 11.33. And that's how you find all of the lines for the rectangle. That should make perfect sense to you based on all the things that we've talked about so far. And last but not least, interpolation and extrapolation. I kind of talked about that. Interpolation occurs when we estimate between given data points. So between these 2 points, if I estimate, this is 2005 to 2010, if I estimate for 2007, that would be considered interpolation. But if I estimate for like what is about 2000, or if I estimate out here like 2030, that's called extrapolation. And extrapolation occurs when we estimate outside of the given data. Typically, interpolation is usually more accurate than extrapolation. But if they ask you to extrapolate something, they're asking you to basically project out outside of your data set. Modeling investments for cloud computing. So you can see they've got 5 different coordinates here. It says make a scatter plot of the data. You can see that scatter plot down here in the left-hand corner. It says find a formula in point slope form for a linear function f that models the data. If I want to find a formula, let's just take 2 coordinates, 2005, 26, and 2009, 374. And let's find the slope. That's going to be 374 minus 26 over 2009 minus 2005. So when we do 374 minus 26, we get 348 over 4, and that becomes 87. So that means 87 investments per year. Now I can use that slope to make my equation. I can plug in one of these coordinates, so I'll plug in 2009 and 374. So I have y minus 374 equals 87 x minus 2009. And that's the equation. So that's for part B. Part C, it says graph the data and y equals fx in the same plane. So there's the data, that's it graphed. Okay? Interpret the slope of the graph. Well, I already did that. This was part D. I just interpreted the slope as the investments per year. And then estimate the investment in cloud computing in 2014. Does your answer involve interpolation or extrapolation? Well, if I say 2014, 2014 is not in my data set. Right? If you look at all this, it's not in my data set. So that must be extrapolation. So we're going to extrapolate. And when we extrapolate, we say y minus 374 equals 87. And we plug in 2014 minus 2009. That's going to give you y minus 374 equals 87 times 5. So that's going to give y minus 374 equals 435. And then we add the 374 over and we get 809. So 2014, we should expect to have 809 investments based on our 87 investments per year. So that's called extrapolation. I hope this video is helpful. See you tomorrow.